Question 3. Particle of mass 20 kilo. Here it's on a smooth plane. Inclined at an angle A or alpha to the horizontal, and tan alpha is 4/3. Tan alpha is 4/3. Hypotenuse is 5, so the sine of alpha is 4/5. And the cos of alpha is 3/5. I like to do this at the beginning of the question. It's nice, easy, kind of just get your pen on the page for a new question and get some correct information down. So we're told it's connected to this 15 kilogram particle by a light in a sensible string, smooth pulley, to find the common acceleration of the two particles. So we've no mu involved here. So let's look at our 20 A. I have my reaction. Don't need it in this case, but I have mg coming down this way, so I have 20g. So in this direction, I have two different forces and my angle A. So along here I have 20g, it's cos of the angle, and 20g cos A is going to be 12g. And then in this direction here, I'm going to have 20g sine A. That's going to be 16g. 8 and 8, 16. So we have our string going this way. So you've got tension. So the only things I have going on here are T minus this guy here. It's the only one going back. So that's 16g is equal to ma. So 20, and I'll have my acceleration is going in that direction, 20a. Well, it actually asked us the 15k rise or fall. Is 20 going to go down or up? Well, let's have a look here. Let's presume that the 15 goes down and the 20 goes up for now. So let's have a look at the 15. I have my string, so my T. We're saying A went up, so let's say A goes down here. And we'll see something happening if we're in the wrong direction, down this way, mg, 15g. So my equation is 15g minus t is equal to ma, 15a. If I bring that equation over here, I'm going to get minus t plus 15g is equal to 15a. You may see here, we're going to get minus g is equal to 35a. So a is a minus number, a is equal to minus g over 35 meters per second squared, and there's a relationship between 9.8 and 35. This is going to give me minus 0.28. You want to simplify it? Meters per second squared. Now, as we said a was going this way, and we got a to be negative, it's actually going in this direction. So the 15 kilo rises. I nearly circle fall. The 15 kilo is going to rise in this case, and we had a going that way being positive, but it was negative, so it's going in the opposite direction. So is that all for question 3? Question 4, a bit more going on here. 5 kilogram particle on a slope, and we're told the inverse sine is 3/5. We have an 8 kilogram mass up here and a 20 kilogram mass over the other side. Okay, let's look at one at a time. Let's look at the 5. We have in here, I call it the angle A, and we're told the inverse sine is 3/5, so the sine of A is equal to 3/5. So the cos of A would be 4/5. So going down in this direction, we have my alternate angle, and we have down in this direction, down here we have 5g, here we have 5g cos A, which is equal to 4g, the 5's cancel in this direction. I have 5g sine A, which is equal to 3g. I have my or, I have my t, no mu in this case, no mu. So my equation here, the only thing going in the opposite direction to t is this guy here, 5g sine A, which is 3g. So we're going to have t minus 3g is equal to ma, which is 5a. So that's the first equation. So the AKG, it's on the table. It's two different strings. So I'm going to go back and, well, I'll just leave the first one as t. I'll call the second one t1. It's AKG, so we have 8g. We have my reaction. There's no mu in this case. So let's look at our equation. Going, the 20 is going to go down, so it is going that. We had the 5 going up, so this has to be going in this direction. So we have t1 minus t, they're the forces, they're the only two, is equal to ma, which is 8a. If we look at the 20 kilo, so we just have the string, which is t1, it's going down, an acceleration of a. We've got mg or 20g, so we have 20g minus t1 is equal to ma, which is 20a. And if I line all of these up, they should cancel off. Have I got a minus? I have a plus t1, yeah, I do. I have a minus t1 plus t1, so t1, that was minus t, equals 8a. That was plus, and then from the top equation, the plus t and the minus 3g is equal to 5a. So you can see the t's all cancel here, and we're left with 20g minus 3g, which is 17g, is equal to 33a. So a is equal to 17g over 33 meters per second squared. What else are we asked here? What are we asked? Find the common acceleration. We've gotten that in terms of g. If the surfaces are smooth, if the surfaces are all rough, the coefficient of friction a quarter. Okay, so we have to change these equations around now. The coefficient of friction is a quarter with 5. I'll change color and we can see it a bit clearer on the current diagrams. So coefficient of friction is a quarter. So back in this direction, I have mu or is equal to my 5g cos alpha now comes into play, so 4g, and the coefficient of friction is a quarter, so mu or is equal to g. So the equation will become t minus 4g. That makes sense. Is equal to 5a. T minus 4g is equal to 5a. Just an extra g getting taken off here. With my 8 kilogram mass, I have mu or in this direction. In this case, or is equal to 8g. So mu or is equal to 2g. So I have 2g going in that way. And I have 2g going in that way. They will obviously cancel in this question. So we are going to be left with, no, not including that. So I'm left with t1 minus the 2g minus the t is equal to 8a. We're not looking at the friction twice, just ignore that. Error. And then we have the 20, which there is no friction involved in. So let's look at our three equations. T minus 4g is equal to 5a. T1 minus t minus 2g is equal to 8a. And 20g minus t1 is equal to 20a. 20g minus t1 is equal to 20a. We can see the t's cancel, and we're going to be left with 14a is 14g is equal to 33a. So a is going to be 14g over 33 meters per second squared.